Hey math kids, today we're going to talk about the association between numerical variables, and the first thing we're going to talk about with respect to that is correlation. And simply put, if we had something like a dot plot that looked like one of these, if we were able to draw a line through it that roughly represents that data and it was positive, we just call it it would be called positive correlation if the slope of the line is positive. And then if we can draw it through and the slope of the line is negative, we call that negative correlation. And then if we have something that just doesn't seem to have a line going through it, we just say it has no correlation. Okay? Now, correlation doesn't have to be linear. If we have dots that look like this, obviously that is going to be linear correlation. If we had dots that looked more like this, maybe that would be exponential. Okay, we could also have quadratic. You can have any type of function for correlation. Okay, now strength, we have strong, moderate, or weak. The strongest for like a linear, and let's just talk about linear for a second. This would be extremely strong because we can actually draw a line through it. Now, if a couple of those dots were a little bit off, it would still be considered strong correlation. Now, moderate correlation is going to be something like this, where the dots, none of the dots really go through the line, but it's still pretty strong to say that that's linear correlation. It definitely has an upward trend, and it tends to be pretty linear when we look at that. And then weak is where like we can barely tell that it has an upward trend, but it's spread out quite a bit, and we're like, okay, that's going to be weak. Okay, this one was moderate. Okay, so as far as this class goes, we're just going to say strong, moderate, weak when we're talking about correlation. And then one last idea. Let's say we have a strong correlation for all of our points, except for one is way down here. We would call that one an outlier. Okay? And then another point that your book wants to make about this is correlation between two variables does not imply that one variable causes the other one to happen. And so you can, there's actually a website, I don't know it off the top of my head, but you can look at all these things that definitely don't affect each other, but they create strong correlations. And so it's just interesting to see. Other than that, I don't have anything else to say on this video. If you need additional help, please come to Math Lab. Until then, calculator.